Hello friends, in this video we are going to study the designing of the embedded system. We will study that what steps are taken whenever an embedded system is designed. Then we will see the design matrix and the optimization done in the design matrix. So let us start with our topic. We know that an embedded system is a system in which the software is embedded in the hardware, and both this software and the hardware part is performing some specific task, and this embedded system is used for a specific or particular application. So whenever an embedded system is designed, then there are some steps and procedure which are to be followed during the designing process. So the designing of the embedded system, it consists of three main parts. First is the design process. So first step is the process, that is the design process which is to be followed. Second is the design matrix. Design matrix means the constraints or the rules that set procedure or set values, that these values are to be maintained during the designing process. Like the embedded system, it will consist of different components, okay, and each component will have different specifications. So what are the set standards and set specifications for the various parts of the embedded systems, and what features are to be expected from the embedded system? The set standards are come under the design matrix. The third step is the optimization in the design matrix. The design matrix consists of the constraints or the specifications for the embedded system, and how these specifications can be optimized during the designing process, that comes under the third step, that is optimization in the design matrix. So the embedded system design or the designing of the embedded system, it will consist of these three main parts: the designing process, the design matrix, and the optimization in the design matrix. So we will study these three topics under the designing of embedded system. Let's start first with the design process. Whenever any embedded system is designed, then there are various tasks which are performed. In that, the first task is the modeling of the system which is to be designed. Okay, so first of all, the embedded system which we want to design, first we have to model that system, and modeling is done by drawing the block diagram of the embedded system. First we will get to know that in that embedded system, what are the components which we have to include, and how these components are connected with each other, where the input is coming from, where we are getting the output. Okay, so first of all, the modeling of the system which is to be designed is done, and in that modeling includes the block diagram implementation. So first task will be the modeling the system to be designed and finding the constraints. In that, our first step will be block diagram of the system. is implemented. So first of all, we will draw the block diagram of the embedded system. Now in that block diagram, we will have different blocks. Now these blocks will represent the various components of the embedded system according to that application. That for some specific application, the block diagram will be different. For some other application, the block diagram will be different. Okay. So according to the application for which the embedded system is to be used, according to that application, we will use the different components and we will draw the block diagram. Now in that block diagram, we will have various components. So each of the block in the block diagram, it will require some circuitry. Okay. So our next step will be to find out that various circuits, that what are the circuits which are to be required to implement that block. So various circuits required to implement the blocks, that will be our next step, and how these circuits will be available. Okay. Sometimes like if we require that in that embedded system, one of the block is the processor. Now the processor, for the processor we will require the input lines, the output lines. Okay, which type of microprocessor is required, so how this microprocessor is available, what are the constraints which are to be followed, what specifications, that how many address lines should be there, how many data lines should be there. So our next step will be that in that block diagram, to implement each of the block, which circuits are required and what are the constraints on that circuits, how these circuits can be available to us, that is our next step. Okay, so various circuits required to implement the blocks and their availability and cost constraints are to be considered. Now this is because our first step is the modeling of the system. So in that modeling, we know that embedded system, it consists of both hardware part and the software part. So hardware part is covered in the block diagram and the various circuits. Now for the software part, we need to experiment and analyze the various blocks and the various circuits. We will use that what type of software is required for us, and in that software we will have different instructions, different data is there. So what type of data is required in that embedded system, what type of instructions are required, according to that we will choose the software for that embedded system. So we need to experiment and analyze. Means to implement that application or that embedded system, what type of software is required. So for the software part, we will use different algorithms, we will experiment those algorithms, or we will analyze those algorithms for that particular application, and we will see that what is that which of the algorithm is performing better. Okay, by seeing their space and time complexities, that how much space that algorithm is acquiring in the memory and how much time it is taking to execute that program. Okay, to execute that calculation, how much time it is required. So in the software part, we need to experiment and analyze with various algorithms and their space and time complexities. Now this embedded system is going to perform various tasks Okay, so the big task of the embedded systems, they are divided into small tasks, and these tasks are given to the various blocks. So huge task of the systems means major task of the system, they are divided into subtasks, and their interactions are to be modeled, that how these tasks are to be performed, and during the working of those tasks which of the circuits are to be involved, and how these circuits are going to interact with each other. Everything we have to modeled in that first step. So that first step in the designing of the embedded system is the modeling of the system and finding the constraints, that what rules are to be followed and what standards are to be maintained. Okay, and in after doing this first part, we have reached to a situation where we have got the block diagram of the system, and we have known that how the various blocks are connected with each other, what is the function of each block, and how they are interacting with each other. Okay, now next step in the designing process is the refinement of the hardware and the software. In this step, because we have already known that what circuits are included in the system, so that is the hardware part, and which algorithms are to be used, that comes in the software part. So in the second part, we will do the refining of the hardware and the software, so that the hardware and the software part, it can perform better in the system. Okay, their performance is increased. So refining is done, that if any modifications can be done in the hardware part, if any modification can be done in the software part, like in the algorithms, how we can improve them, those algorithms, how we can improve the circuits in the system, that is done in the second part. So the second part is the refining of hardware and software. Now, how the refining can be done? Because we know that the hardware part, it includes the circuits and the various blocks. So, how much power these circuits are using? Okay, that is their power consumption can be measured. The designing should be such that these hardware parts, they should consume very less power. Okay, so in the second step, that is refining of hardware, we will try that all the hardware parts, they should be such designed that they are consuming very less power. So one of the measurement or one of the task in refining is like power consumption measure we can done. For the software, we can check the time the algorithms are taking for doing the mathematical computations, like how much time the algorithm is taking to perform a mathematical calculation or doing some complex arithmetic calculation. We will see that which algorithm is taking less time and how we can reduce that time taken, how we can reduce the steps in the algorithm so that the time is less. Okay, so this is how the refining of the hardware and the software part is done in the second step. Third step is, after the refinement, partitioning of the hardware and software is done. So after the designing of the hardware and the software part, after their refinement, then partitioning is done. That separate work is allocated to the hardware and to the software. That this task of the system is to be performed by the hardware components, and this part is, or this task is to be performed by the software part. Okay. is the separate working on the design hardware and the software is to be done. So how it is done? Allocating the and the software is running on custom or general purpose hardware. Means to every block in the block diagram, we will assign that this task is to be performed by this specific circuit and this task is to be performed by the another circuit. So for every block we will assign that which tasks are to be performed by them, and in the software part we will see that whether the software will run on the custom or the general purpose hardware. Okay, like for example that in the embedded system we have timers and counters. So at this stage we will decide that whether the timer is to be implemented by the hardware part or by the software part. We know that the timers, they can be implemented with the help of the instructions also and with the help of hardware, that is with the help of pins also. Okay, in the chips we are having specific pins in the microprocessor. So with that hardware part or hardware circuitry also the timers can be implemented, and with the software part also through the help of instructions also timers can be implemented. So partitioning of the hardware software means that at this stage it is to be decided that whether the task is to be performed by the hardware or by the software. So separate allocation of the task is done in the third step. Now the next step is scheduling. Now, once the partitioning of the hardware and software is done, means that separate tasks are allocated to hardware and the software. Now, after that, scheduling is done. Scheduling means that which task is to be performed first, after that which task is to be performed, means the sequence in which the tasks are to be performed. Suppose that there are two tasks and they are sharing the same resource. Okay, means that address lines are there in the microprocessor. Now these address lines are to be used by two blocks. So which block is going to use the address lines first? Okay, so in this way the sequence of tasks, that in which way the tasks are to be performed and which resource is to be used first, that is decided or scheduling is done. Okay, so in this steps, scheduling refers to it refers to the allocation of the time steps for several modules sharing the same resource. Means in the embedded system we are having the different modules or different blocks, different components are there. So suppose that these components are sharing the same resource. So how this resource is to be used by these different modules, then the time slots are allocated to each of these modules, that this module is going to use the resource for this much time, and the priority that this module is going to use the resource first, this is going to use it at the second step. So allocation of time steps for several modules sharing the same resource is done in the fourth step. So in this scheduling part, if a resource is shared by the various modules and at the various stages of the design it is to be used, then it should be done by the scheduling. Means that the required task should be completed as and when required. The task should be completed timely, and the way in which that task is to be performed, that is to be followed of the various parallel working tasks. Means suppose that many tasks are to be done at the same time by the module or by the embedded system. So out of these parallel tasks, the required task is to be complete at time. Okay, so that is called the scheduling of the system. So in this fourth step, the scheduling or the allocation of the time slots is done. The next step is the implementation. Now, up till the fourth step, we have got the hardware and the software. So, in this fifth step, that is in the implementation, actually the hardware is going to be implemented and the software is to be implemented. How the hardware is implemented means we are going to connect all the components together in the way in which they are to be represented in the block diagram. In that way, with the components will be connected. So actually the hardware will be implemented, and in the software part we will do the code generation, like because we are using the embedded system for a particular application. So for that application, how the program is to be written, that is, or how the algorithms are to be used. So in this step, in the fifth step, implementation, the code generation is done in the software. So actual hardware building and software code generation is done in the implementation step. Now next step is simulation and validation. Now once the software is implemented, means we have generated the code. Now this code is to be simulated because this code has to be connected with the hardware part, and we will see that how it is working, whether it is giving valid results or not. So in this sixth step, the simulation is done. So in this part, the software is simulated. How it is simulated? It is interfaced with the hardware implemented. Means the hardware and software part, they are connected with each other. The software which is generated, the code which is generated, that code is run on the hardware part, and we will get the result, that how the code is running on the hardware part. So this software is simulated on the system and it is validated for its working, that whether it is giving the valid results or not. If it is not giving the valid results, then we have to do the corrections in the software, and we will see that whether the embedded system is can be used for that specific application or not. Now last step in the designing process is iterate. Suppose that in the second last step, that is in the simulation and the validation, if the validation of the system goes wrong, that the system is not giving us the proper response, the proper results are not being given, then the above process, that is again the modeling of the system, again the refinement and implementation and scheduling, again all these steps are to be repeated, so that the embedded system, it should be designed in the proper way. So in the iteration, in the last step, if the validation goes wrong, so that is the last step in the designing process. Okay, so in this embedded system design, we have seen that first of all our main step is the modeling of the system. We have to find out that which blocks are to be required, which circuits are to be required, whether these circuits are easily available or not, and what constraints are to be followed for those circuits. After that, we will see that how the tasks are to be performed by the hardware and software, in which way they will perform it. Then we will implement the software on the hardware. We will check that whether the system is giving us the proper results or not. So this is the design process which is to be followed, and these are the steps. Okay, now after that we have the design matrix. So next is the embedded system design matrix. Now, what is the matrix? Metric means the standards or measurement, or the standards or rules by which we can define the efficiency, the performance, the quality of a process or a system. So in the design matrix, we have the specific values, like these parameters or these values are going to define that the embedded system which is designed by us, that is of good quality, and how its performance is going to be, and what is will be the progress or the size or efficiency of that system. Okay, so whenever we are designing the embedded system, then these points are to be considered. Okay, so that the embedded system will be of good quality, its efficiency will be good. Now in this, the first is the unit cost. The first design metric is the unit cost. Unit cost means that the cost of each unit. Now this cost, it includes the components cost and the man cost involved in it. Okay, means that in the embedded system we will have different units. Okay, so these units will be made up of different components. So what is the cost of each component, plus during the building up of that unit, or during the designing or manufacturing of that unit, how much manpower is required. Okay, so that is called the man cost in it. So cost of each unit will be comprised of the component cost plus the development cost. Now in this we are excluding the cost of development. The first time when the system is being designed, at that first time the cost of development, that cost is excluded in this unit cost. So unit cost will include only the components cost plus the man cost. Okay, so this is the first design metric. Second is non-recurring expenditure. is NRE cost. Non-recurring expenditure cost means that the cost which is not repeated again and again. Okay, means that once we have done the investment, then there is no need to do the investment again and again. Okay, so non-recurring means it is not occurring again and again. Expenditure means one-time investment we have done. Okay, so this is going to include the cost which is not going to repeat. This is only the one time investment for the designer. Costs that are incurred only once and are not for each system. Okay, means every time there is no need to do the investment, there is no need to do the expenditure. One time you have done the expenditure, then it will be done. Now this type of cost will include the development cost. Okay, and the other investments that are to be done. So in the unit cost we are including component cost plus the man cost, but development cost is not included. In the second non-recurring expenditure cost we are including the development cost. Okay, third design metric is the size. The size is also an important parameter. When we are designing the embedded system, it will have the hardware and the software. So the size of the hardware and software is also very important. Okay, means that if the size of the components is very large, then the embedded system is going to acquire very much space. Also, for the software, in the software, if there are very long algorithms, then those algorithms and programs are also going to use very much space or memory. Okay, so size is also an important parameter. That is for the software. If we take the case for hardware, then the circuits, they are going to acquire the physical space. Like if the circuit is very big, then it is going to acquire a very large space. So for the hardware, it includes the physical space required. So size is also an important parameter for the embedded systems. Next is its performance. Now performance is also an important parameter, and if we want to find out that how the embedded system is performing, then we are going to compare that embedded system which is developed with the existing embedded system. Okay, suppose we have designed a new embedded system, then we want to see that how efficient this system is, how its performance is. Then we are going to compare this new embedded system with the existing embedded system. We are going to compare them and we will see that which embedded system is performing better. So performance is a comparative measure compared with existing systems. And this comparison is done on the basis of different parameters. Okay, like we will see that what is the response time. We will check that which system is responding faster. Then we will check their speed. Okay, their power consumption, we will check that which system is consuming less power. So on the basis of these parameters, we will do the comparison, we will check that which system is performing better. Now next design metric is power consumption. Now, in an embedded system, power consumption is a very important parameter because most of the embedded system, they are battery operated. So in that case, the power consumption becomes a very important thing. Okay, so an embedded system, ideally it should consume very less power. Okay, so this is also a design metric that when the designing of embedded system is done, then power should also be considered as one of the important parameters. Flexibility means that if we are changing the application of the embedded system, then how much changes we have to done in its blocks and its components. Okay, so flexibility means that it is a measure of cost changing certain operational behavior of the system. Okay, so when we are doing the changes in the embedded system, like if we want to change the behavior of some of the parts, then how much cost is involved in that changes, that is come under the flexibility. That how flexible our system is, that if we are making small changes in its behavior, then some small cost is required there. Okay, if large cost is required, it means that our system is not flexible. Okay, now here the cost is the non-recurring cost, because once we have made the changes, then those changes are going to persist in the system itself. Next design metric is the time to market. Now once the embedded system is being designed, now that embedded system, first we make the prototype of the embedded system, then we make copies of that system, and then we distribute that system in the market. Okay, so how much time will be taken by the system to come in the market, that is called the time to market. Okay, and this time to market should be as less as possible, means that when the system has been designed, then immediately it will come into the market. Okay, so this time to market involves the time to prototype, means first we are going to make the prototype of the system. Okay, now once the system is being developed, then how much time we are taking to refine that prototype, because some changes are to be made in that system so that its performance is getting better. Then after that, the time to produce it in bulk. Like takes the example of the watch. Watch is also an embedded system which is called the display system, which is displaying us the time. Now in the watch, first we are going to make the prototype of the watch. Okay, then we will do the refinements, that whether the watch all the parts are correctly placed or not, and it is indicating us the right time or not. Okay, so how much time is taken to take the refinement, then the watch is produced in bulk, and then it is put in the market for the selling purpose. Okay, so time to prototype, time to refine, and time to produce in bulk constitutes the time to market. Next design metric is the correctness. Now we have designed the system, but that system should be a correct system, a valid system. Okay, so correctness and validation is also very important. Okay, it is not that we have designed the system and it is not giving us the proper results. So correctness should also be kept in mind, that is test and validation of the system. Next design metric is its safety. Okay, the system should be safe as well. It is not that safety measures are not kept in mind, so safety is also an important aspect. So these are all the design metrics which are to be kept in mind while doing the designing of the embedded system. Now in these design metrics, they are often contradictory with each other. Means if we are following one design metric, then maybe there that other design metrics they are changed. Okay, so all this contradiction between the design metrics, it needs the optimization. Means that there should be an state which is the optimized state in all these design metrics. Okay, we should design a system which is following all these constraints in an optimized way. Okay, now in this optimization, various parameters are also playing its role, like the processor choice, that which type of processor is used in the embedded system, then partitioning decisions, what type of decisions are taken, like we have divided the task between the hardware and the software, we have done the partitioning of the task, so how the tasks are being divided between them. Then also compilation knowledge, expertise in hardware and software. So in the optimization, all these points are kept in mind, that which type of processor is chosen, which types of decisions are taken, compilation knowledge should be there, and expertise in hardware and software is also required. So our next step in the designing of the embedded system is the optimization in design metric. So first thing in the embedded system is that the embedded system, it consists of various components. Okay, so these component requirement, it should be as less as possible. Okay, so optimization can be done by minimizing the number of the components required in the embedded system, while the specification, like the application for which we are using the embedded system, that should be maintained. Okay, so component, because if component requirement is less, then the cost of the system is also reduced, the size of the system is also reduced, and the space which the system is acquiring, that is also reduced. So by reducing the component requirement, we are optimizing the system. Okay, but if we are reducing the component requirement, it should be maintained that all the other requirements should be maintained. So this is the first way in which the optimization of the system can be done. Next is In the embedded system, we know that the main part or the heart of the embedded system is the microprocessor or the microcontroller. So second way of doing optimization is by optimizing the microprocessor and the microcontroller used in the system. How we can optimize it? We can say that the cost of the microprocessor or microcontroller, it should be minimum. Okay, so microprocessor or microcontroller, that is to be optimized. So for that, its cost should be low. Also, its power consumption should be low. Then we have its performance should be good. And there are other design metrics also which should be fulfilled for selecting the microprocessor or microcontroller for a particular embedded system. So another way of optimizing the system is to optimize the microcontroller or the microprocessor. And how we can optimize it? We can choose any of these parameters like cost, power consumption, performance, and the other design metrics like size can be considered. Okay. Now, after microprocessor, the another important component of the embedded system is the memory. Now, optimization can also be done by optimizing the memory. And we know that in the embedded system, there are two types of memory. One is the program memory and other is the data memory. The program memory is called the ROM and the data memory is called the RAM. So to optimize the memory, both the program and data memory, they should be optimal. Like if we talk about the program memory, okay, so in the program memory it can be optimized when we are using the program code which is of very short length. Okay, the length of the program should be small. Okay, in program memory, the program code, okay, that should be optimum. Now if we talk about the data memory, then data memory should also be optimum. In some embedded system, there are other types of memories also which are required, like the external flash memory or the EEPROM. External flash memory or EEPROM. So to optimize the memory, both the program memory and the data memory, they are to be optimized. Program memory can be optimized by using an optimum code for the application, and data memory can be optimized by using the different types of data types. Okay. Now, after the microprocessor, microcontroller, and the memory, the another important component of the embedded system is the peripheral devices. Peripheral devices includes both the input devices and the output devices. In some embedded system, the peripheral devices, they are externally present, and in some embedded system, they are internally present in the system. So sometimes they are internal to the processor and sometimes they are external to the processor. So these peripheral devices, they should also be optimized according to the requirement. That according to a requirement, the number of input output devices should be decided. Also their size and their circuitry should be decided. So as per our requirement, the peripheral devices are optimized. Now the other things which are to be kept in mind while optimizing the embedded system are like the power supply current, and voltage requirements, development and manufacturing cost, clock rate reduction, and operating voltage reduction. So these are the other parameters which are to be kept in mind while we are optimizing the embedded system. So here in this video we studied that what are the important points which are to be kept in mind while we are designing an embedded system. In that topic, we studied first the design process, that what steps are to be taken when we are designing an embedded system. After that, we studied the design metrics, that what standards are to be maintained, are to be kept in mind, or what parameters are very important in the designing process. After that, we studied that how the design metrics, they can be optimized by the system. Okay. So I hope that this topic, embedded system design, is now clear to you. Thank you.